Analysis of RC circuit. We have a resistor R in series with a capacitor C. This is connected to an AC voltage source of frequency F Hz. The R and C form a complex impedance, a capacitive load. This load has a complex reactive component to it known as the capacitive reactance. Xc is equal to 1 by 2 pi F into C. This capacitive reactance causes the current to lead the voltage. That makes the capacitive reactance along the positive imaginary axis. The total impedance of the load is Z equal to R plus J Xc. We need to find out the current through this circuit and also the voltage across the resistor and the capacitor. Since all the elements in this circuit are in series, the current through them will be the same. Let the input voltage be V, the voltage across the resistor be VR, and the voltage across the capacitor be Vc. The input voltage will be equal to the sum of the voltages across the resistor and capacitor. That is, V is equal to VR plus Vc. Let I be the instantaneous current through the circuit. Let us draw the phasors corresponding to the voltages and current in the circuit. Since current through all the elements is the same, we will take it as the reference. Now, voltage across a resistor will be in phase with its current. So, VR can be drawn along the same axis as current I. The magnitude of VR is equal to I into R. The voltage across a capacitor will lag its current by 90 degrees. So, Vc can be drawn 90 degree downwards from the current axis. The magnitude of Vc is equal to I into Xc. The applied voltage V is the phasor sum of VR and Vc. So, we can draw V like this. From this figure, V square is equal to VR square plus Vc square, which is equal to I into R the whole square plus I into Xc the whole square, which is equal to I square into R square plus Xc square, or V is equal to I into square root of R square plus Xc square. V is equal to I into Z, where Z equal to square root of R square plus Xc square and is the impedance of the circuit. So, we can write I is equal to V by Z. Let this be equation number 1. Here, VR, Vc and V form a right angle triangle with V forming the hypotenuse. The angle between V and I is called the power factor angle of the circuit. It is represented by the symbol phi. This is the phase difference between the voltage and current. Since applied voltage is the known quantity, we take it as the reference. So, voltage is V of t is equal to Vm sin omega t. The current waveform will have the same frequency as the voltage but different amplitude and phase. So, I of t is equal to Im sin omega t plus phi. This expression shows that the current leads the voltage by an angle phi. Comparing this with equation 1, we can say that Im is equal to Vm by Z. Also, from the voltage triangle, we can write tan phi is equal to Vc by Vr, which is equal to I into Xc divided by I into R, which is equal to Xc divided by R, or phi is equal to tan inverse Xc by R. So, we have derived the expression for the current in an RC circuit in terms of the circuit parameters.